Hello, this is section 6.6 Nonlinear and Inequality Systems. Objectives: number 1, solving nonlinear system. Number 2, applications of nonlinear systems. Number 3, graphing the solution set of the inequality system as um, the linear or the nonlinear the inequality. So nonlinear system. This section is final section of this chapter devoted to the study of system. However, unlike the first 5 sections, which is only include the linear system, and this section will contain the system with the nonlinear equation, which means you might not gonna get the line. And then also the system of the inequalities. So a system of the nonlinear equation is any system that contains at least one equation is not linear. So the linear system is the section is will most often contain the variety of the conics, but the system with other equations such as a polynomial or radical equation will be encountered. Before solving any nonlinear system, we must discuss the possibility for numerous answers for the single system. Unlike the linear system that have either none, inconsistent, or one, or infinitely many solutions, which is dependent case, nonlinear system can have any number of the solution if include the polynomial equation of any degree. So in this section, we will encounter examples with anywhere from 0 to 4 solutions. So we might get the 0 or 1 or 2 or 3 or 4. So the following sets of graphs possibilities for how a nonlinear system to have a none or 1, 2, 3, or 4 solutions. So two solution means, what if you have a ellipse, and then when you have a linear, which it doesn't meet, this is the case of the no solution. One solution means when you have a, let's say, the circle, and then one of the line going through the 1 points. So this is one solution case. And two solution means, what if you have a ellipse at a circle, and then they met as a two solution place. So which is solution is the intersection between the two graphs. Three solution means, what if you have what if you have a ellipse, and then you have actually the circle that go through this way. So they meet here to here to here. Okay, for solution case, let's say you have a hyperbola, and then you have a ellipse, which is here to here to here to here. Okay, so you can see through the graph, but we also can use elimination or substitution to find the solution too. So because of the wide variety of the equation that can be included in a nonlinear system, the only two methods used for solving nonlinear systems are substitution and elimination. Furthermore, we will see that the substitution is the only method that can be used to solve all nonlinear systems. However, when elimination is a possibility, the method often allows for more easy in solving. For this reason, we will often start to solve a nonlinear system by asking ourselves to one question: is elimination possible? So if it's elimination possible, use that first. If not, then just use the substitution method. But we cannot use the matrices and then the Kramer rules for this, because the Kramer rules and then matrix only for the system of the linear equations. So we call the basic description of the process of the situation. Number 1, pick one equation and solve for single variable, because we're using for the substitution. Number 2, substitute the expression for isolated variable into the other equation. Number 3, solve the resulting equation. Number 4, back substitute to find the value of the second variable. Also, recall the basic description of the process of the elimination. Number 1, multiply one or both equations by constants so that the one variable will have a coefficient that is opposite. Add two equations. and solve the Bridgerton equation. And number 4, back substitute to find the value of the second variable. Okay, so example 1, which is there's no way we can use elimination because first equation has a degree of 2, but the second equation is degree of 1. So there's no way you can use elimination because elimination means addition method, which is you cannot add or subtract by the unlike terms. Unlike term means like term means they must have the same degree. So this time we have to use a elimination. So I want to label the first and second equation. So I'm going to pull out the equation 2, and then I'm going to solve for x. You can also solve for y too, but you have to divide by -1. So solve for x means I'm going to add the y both sides. So x equal to 1 plus y. I call this the 2 prime. Now we are ready to plug it in 1 plus y into the equation 1. So now I have now I have 1 plus y squared equal to 25. So if you score the binomial, this is actually the same as this. And then you can just FOIL. But if we do is you got 1 plus 2y plus y squared equal to 25. And then combine like terms. So I got 2y squared plus 2y and subtract 25 both sides. I got 24 equal to 0. I factor out the 2. I got y squared plus y minus 12. And then divide by 2. You can do that because the 2 is a factor. And then we can reduce the coefficient of the equation. And then it's a factorable. So y plus 4 times y minus 3 equal to 0. So your y is -4 or y equal to 3, which means you get the other x too. So use the equation 2 prime we have here. And then I'm going to solve for x. So x is 1 plus -4, which is -3. So your solution is -3 and -4. And then x equal to 1 plus 3, which is a 4. So you got 4 and 3. So these are the solution for this example 1. Now example 2. Example 2 I can use elimination because they have a like term. So equation 1 and equation 2. So but this time I'm going to multiply equation by -2. So what do you mean is -2 of x squared plus 4y squared plus equal to 25 times of -2. So distribute the -2 x squared minus 8y squared equal to -50, which is the equation 1 prime. And then I am adding with the equation 2. So add them up. Cancel -11y squared equal to -44. And then if I divide by -11 both sides, and then y squared equal to 4, which means y is a plus minus 2. So which is y is a 2 or y is a -2 this time. Now I'm going to use a substitution, which is I want to use the equation 1. So equation 1 has x squared plus 4 of 2 squared equal to 25. So x squared plus 2 times 2 is a 4, 16 equal to 25. And subtract 16 both sides, x squared equal to 9, x equal to plus minus 3. So which means when x is a plus minus 3, y is a 2. Y equal to -2, which is x squared, same equation, equation 1, plug it in, -2 squared equal to 25. But negative becomes a positive by square, so it's going to be 16 again. So subtract 16 both sides, 9, x equal to plus or minus 3, which means plus 3 minus -2. Which means there are 4 solutions, which means you got 3 and 2, -3 and 2, and 3 and -2, and you got -3 and -2. So you got 4 solutions for this case. Alright, number 3. Solve the system of the equation. So, this one just a substitution right away. So I'm going to plug it in this equation to right there. So I got x squared plus x squared minus 4 squared equal to 16. X squared, which is x squared minus 4 squared, means x squared minus 4 times x squared minus 4 equal to 16. So I got x squared. And then I got x to the 4, you got 4, right? 4, x to the 4 minus 4x to the 4 square minus 4x squared plus 16 equal to 16. If I subtract 16 both sides, I got x to the 4, and then negative 8, negative 1 in here, so negative 7x squared equal to 0. So I can factor out the x squared. I got x squared minus 7 equal to 0. So we get the 4 solution, but the x squared equal to 0, x squared minus 7 equal to 0, because x squared minus 7 is not factorable. So I have x equal to 0, so you got one solution from here. And then plus 7 both sides, x squared equal to 7. Use the square property, which is x equal to plus minus y equals 7. So you have actually the 3 solution. So when x equal to 0, and then use equation 2, y equal to 0 squared minus 4, negative 4. So you got 0 and negative 4. Now x equal to radical 7, y equal to radical 7 squared minus 4, 7 minus 4, which is a 3. So radical 7 and 3. And x equal to negative radical 7, which is y equal to negative radical 7 squared minus 4, which is 7 minus 4 equal to 3, which is negative 7 radical 7. So we got 3 solutions for this case. So in this first 3 example, we had a solution set has contained 2, 3, or 4 solutions. In the next 2 example, we'll see that 2 different results that each reveals a system of no solutions. Okay, so example 4, I have equation 1 and 2. So this time, equation 1, I'm going to multiply by negative 1. That means I got negative x squared minus y squared equal to negative 4, which is 1 prime. And then I'm adding the equation 2 and 1 prime. Cancel. Oh, cancel. So I got 5. Which means this is not true. So this is case of no solution. Which means this 2 is a circle which never meet. So because 1 is a radius 2, and then 1 is a radius 3. Since they never meet, okay? No solution. Example 5. Yeah, I think I want to use elimination too. So if I use elimination, equation 1, I'm going to multiply by negative 1. So negative x squared minus y squared equal to negative 6. And then I'm going to add it up. So I got negative x squared plus 2x and y squared cancel equal to 5. So I'm going to subtract 5 both sides. I got negative x squared plus 2x minus 5 equal to 0. And then I'm going to multiply by negative 1 to both sides. X squared minus 2x plus 5 equal to 0. This equation is not vectorable, so I have to use a quadratic formula, so which is negative b plus minus b squared minus 4ac over 2 times a, so negative of negative 2. Negative 2 squared minus 4 times a times c over 2 times 1. And then 2 plus minus 4 minus 20. And then 2 plus minus negative 16. And then I got 2 plus minus 4i over 2, which is cancel by 2. I got 1 plus minus 2i, which is it's not real. So even though we got 2 solutions, but the x is not real, so this is actually the no solution case. Okay, all right. So as we consider the last example of the nonlinear system of the equation, you will see why the end of the every one has a previous example of the solving nonlinear system include a check of the each order pair. Even though elimination and substitution will find all of the solutions T linear system, some choices made during the either process can lead to the finding an extraneous solution. So equation 1 and equation 2, for example 6. So one we have a circle equation, and the equation 2 is a radical equation. So of course I'm going to use a substitution. So I'm going to plug it in equation 2, radical x plus 1 into the y square. So I got x squared of radical x plus 1 square equal to 7. Square the radical means you can pull out that. Then you got x squared plus x and subtract 7 both sides, minus 6 equal to 0. This is a factorable. So your x come out as negative 3 and 2. So plug it in. X equal to negative 3. And then plug it in y equal to negative 3 plus 1, which is a radical negative 2, which is not real. It's an I radical 2, right? It's not real. So even though we have x, but y is not real, so we can take the negative 3, which is this negative 3 we call the extraneous. And then x equal to 2. So y equal to 2 plus 1, and then radical 3. Radical 3 is an irrational number, which is a real number. So we have the solution of 2n radical 3, which makes a one solution case. All right. Application of the nonlinear system. So many applications can ask for the two unknown can be interpreted into a system of two equations. In the next example, we will encounter. So example 7, find the dimension of the rectangle with the perimeter of the 34 feet and the area of the 66 feet. So when we have a rectangle, let's say this is the length and width, which is the length and width. So in order to find the perimeter, which is a 2L plus 2W, and the area is the length and width. Okay, so we know the perimeter. The perimeter is a 34, equal to 2 length and 2 width. And then area of the square is the area is 66, equal to, and length and width. So number 1 and number 2. So can we solve this problem? Yes, we can. So in order to solve, I think I want to use a substitution. So equation 1, I think I want to divide by 2. So 34 equal to 2L plus 2W. I'm going to divide by 2 both sides. Then I get 17 equal to L plus W, equation 1. And then I'm going to solve for L or W. So let's subtract W both sides. So 17 minus W equal to L, which is a 1 prime. Now 17 minus W, I'm going to plug it into the equation 2. So I got 66 equal to 17 minus W times W. And then I got 66 equal to 17W minus W squared. And then if I subtract this 66 both sides, I got 0 equal to negative W squared. I want to put the descending power, okay? And then I'm going to multiply by negative 1 both sides. Then I got 0 equal to W squared minus 17W plus 66. I'm going to find the two numbers from the product of the 66, make the sum of the 17. So when I look, oh yeah, 11 and 6, right? So I think I can factor as a W minus 11 and W minus 6. So I get the W equal to 11, W equal to 6. So plug it in. So in order to find the L, I'm going to use the equation 1 prime, which is this one. So L is 17 minus 11. I got 6. And then the length is 17 minus 6. I got 11. Okay. So we got the dimension here. Okay. So length by width. So it could be the length by width. It could be the 6 feet by 11 feet or 11 feet by 6 feet. Okay, so either way it's possible answer, okay? All right, next problem. Inequality system. So for the final topics of this section and chapter, we will discuss system of the inequality because the inequality system nearly always have an infinitely many solutions. We display the solution set by using graphing and shading the region that contains all the solutions. Before we discuss the system of inequalities, we will begin with the shading of the solution set of the single inequality in two variables. Example 8. So graph the solution set of each of the following inequality. But important thing is inequalities. we have to check for the this and this or this and this, because the graph which is not included for the equal sign is included. Okay, so you have to say this case you have a dashed line or dash graph, and this case we go the solid graph. All right, so y equal to less than 2, so this actually give us the dashed. All right, so now I'm gonna make the equation. Okay, so what I do is, oh, you know what, let me use the slopes. So slope is 2, which is 2 over 1, up to right 1, and the y-intercept is a 0, 0. So from the 0, 0, I'll go 1, 2, and right up, 1, 2, right 1, okay? And then I got the dash. So now what I need is, I need to actually, this dash line actually divides this region and this region. So we need to shade it. So which is size of solution? So what I do is, I need a test point. So test point, you can choose whatever you want except to the point from the graph, okay? So which means I think I want to use, you know what, let me use, what about this? Isn't it 3 and 1, right? So I'm going to use this. So yeah, you can choose any point you want, but 0, 0 or whatever point on the line is not good. Plug it into your original equation, which is this one. So y is a 1, 2 times 3. 1 is less than 6. It is true, right? 1 is less than 6, which means 3 and 1 is a solution, which means whatever point you pick from that region will be a solution. So you gotta shade the place of the 3 and 1 in. Okay, in B, x squared plus y squared equal to 9, which is a circle equation, okay? So you should know when you look it up, okay? So center for this circle is a 0, 0, and then the r is 3, because r squared is a 9. So from the 3, 3, oh, but this is the equation though, so I think that something is wrong. Okay, so I need to make an inequality, so let's put it this way. Sorry about that. Let's put the last name. Okay, so from the 0, 0, I go 1, 2, 3 up, 1, 2, 3 right, 1, 2, 3 down, 1, 2, 3 left. And then I'm gonna make the solid circle because there's an equal sign this time. Okay, and then of course this time test point, you can use a center for test point, because whatever point is not on the circle, we are good. Okay, all right, so you can choose any point you want except any point on the circle. Okay, so I'm gonna use a 0, 0. So plug it in. 0 squared plus 0 squared less than or equal to 9. 0 is less than 9. Is it true? Yes. So any point inside of the circle will be the solution set. Y equal to greater or equal to x squared plus 1. So this is the parabola. So this is going to be the solid, right? So y equal to x squared minus 1. So the vertex is x is a 0 and the y is a negative 1, right? So from here, and then you can use a table if you want. So from the 0, 0, maybe 1 and negative 1. So plug it in, 1 square minus 1, 0. Negative 1 square minus 1 is also 0. So you got 1, 1. Well, sorry, 1, 0. What am I doing? And then negative 1, 0, okay? And then it's a solid. So I just need to make it solid. Okay? And then test point. So test point this time, actually, you don't have, this time you can use a test point as a 0, 0. Because it didn't go through the origin. So 0 is a greater or equal to 0 squared minus 1. So 0 is a greater or equal to negative. Yeah, it is true. So your solution, so 0 is just one of the solutions. So you gotta show it inside. Okay, now that we can grab the solution sets of the single inequality, we can discuss system of inequality. So you have inequality more than one. So for the next examples of the system of the inequalities, we will consider two systems created by using a combination of the sum of the three inequality in example 8. Similar to every other system in this chapter, the solution set of the inequality system will contain all the points that satisfy every inequality in the system. So I'm going to put together equation 1 and 2. So equation 1 is a circle. Inequality 1 is a circle. So x squared plus y squared equal to 9. So circle has a radius 3, right? Remember we did it. And then it's a solid. So what you need is, I'm going to make a circle. And then also, it was inside, right? Because test point 0, 0, which is a center work. Now for the equation 2, which is a line, right? So from the 0, 0, you got 1, 2, all right, which is down and right here, okay? And then it's a dash. And then test point I used was, oh yeah, we actually it was a down, all right? And then the solution set that we're gonna say in here, it's gonna be this place, which is a red and the green and the red and the blue shade together. Okay, so that's all. For the second one, inequality 1 and inequality 2. Inequality 1 is the circle, right? So radius 3 from the center. And then it's a solid, so which is solid circle. Okay, and then it was inside. And the inequality 2 was a parabola, which is we grabbed the 2, which is from the negative 1, 1, 1, 1 and 0, right? And then when is a 2, 4, 3. Okay, and then this is solid. Okay, so this is what it was. And then 0, 0 works, so which is, yeah, you're gonna shade the inside, but the solution set will be the one that is between the shade between the red and the blue. Okay, graph the solution set following the inequality. So inequality 1 and inequality 2. So this inequality, y squared plus y squared greater than 4. So inequality 1, you got x squared plus y squared equal to 4. So center 0, 0 from 2, 2 as radius of the circle. But this time is a dash. This is going to be a dash. And then if I use the test point, oh sorry, zero, 0, 0 squared plus y squared, the y is a 0 too. 0 squared plus 0 squared greater than 4, 0 is greater than 4, which is not true. So which means 0, 0 works, so you have to shade outside of the circle. Any place outside of the circle, okay? So this is a solution set. Now for the second one, it's a line. So equation 2, I got y is equal to negative 1 plus 1. Oh, negative x plus 1. What am I doing? And then slope is negative 1 over 1, down 1, right 1. And then y-7 is a 0, 1. So from 0, 1, you go down 1, right 1, down 1, right 1. Okay, and then this is also dashed. And then test point. This time I think I can use a 0, 0. So 0 less than negative 0 plus 1, 0 less than 1, true. So which means 0, 0 work. So 0 is right here, which is 0, 0 is right here, right? Okay. So which means we need to shade it on this side. Even though we can shade it here, but this is not a solution for the first inequality, so I don't want to shade. Which means the solution set for this one will be the place that is here. So this is the outside of the half of the circle. Okay. All right. Okay. All right. Thank you for listening.